Okay, we have the 4.6 through 4.7 review worksheet right here, where you'll see angle bisector proportional side theorem used, the triangle proportionality theorem, converse, it's touched on briefly, proportional segments theorem, triangle midsegment theorem, and then all the applications we learned in 4.7. And they're just the use of similar triangles applied to real life scenarios. So let's start with just the general idea of the angle bisector proportional side theorem. All it's stating is if you have this triangle here and you have an angle bisector created there, constructed there, then it breaks this triangle into proportional side lengths. So I like to create the color here that breaks it up and shows you that the proportion of 6 to 4 should be the same as, we'll call this x. That side x is to 8. That's all this is saying, the angle bisector proportional side theorem. If you cross multiply, get the following, and you can solve for x. And that's all that's asking for. There's some questions that are a little bit tougher. For example, number 4. Number 4 does not give us either this side length in full, nor does it give us this side length. And we can't call this x because x has already been used. Instead, we have to consider the fact that the entire length of the full side here is 6. And if we want just this side right here, or this part, this segment, we need to subtract out all of this value here. In doing so, you'll notice that this negative must be distributed to the 2x as well as to the negative 8. When you subtract a negative, you get a positive. Okay. So the value here, we'll make this blue, since this is the length here, 6 minus 2x plus 8. Of course, before writing that out, you'll want to simplify this. These two terms combine to make 14. So we'll write 14 minus 2x. Or you could write negative 2x plus 14. It does not matter. Okay. Now to evaluate, we can say that 6 is to 14 minus 2x as green, 3 is to 2x minus 8. When we cross multiply, we get the following. And then we can distribute. It's equal to 30 plus 12, this should be 42, minus 6x. I would prefer to, here at this point, add 6x to both sides and add 48, use a different color, to both sides. So I get 42 plus 48, that should be 90. And over here I get 18x. So 90 divided by 18. There we go. Is 5. Cool. I should have done that in my head. So x equals 5. Now when you plug that 5 back in, you should see some proportionality going on here. So if we do 14 minus 2 times 5, we get 14 minus 10, which gives us 4. And then when we plug it into 2x, where x is 5, minus 8, we get 10 minus 2, which gives us 2. So is it true that 6 is to 4 as 3 is to 2? Well, we know this reduces to 3/2, so we're good. It works out, and you'll notice that 4 plus 2 here adds up to 6. Looks good. Now let's go to the triangle proportionality theorem. It's very similar in that we're just looking at proportions. So as you'll see here, this value is 16, and this value here is 40 minus 16. So what is 40 minus 16? That should be 24. So we can say 16 is to 24 as, and we'll call this side length x, as x is to 42. I'll reduce this fraction here by dividing the top by 4 and the bottom by 4. It looks like we could have done dividing by 8. I'll just reduce this more. This is 2/3. 16/24 reduces to 2/3. When we cross multiply, we get 3x equals 84. And 3 goes into 84. Goes into 90 30 times. So 6 less than that would be 28. Just double check that. 3 times 28 is 24. 6, 7, 8. Cool. Checks out. X equals 28. So this value here would be 28. That's all we're doing. This one will be a little bit more difficult. As you can tell, we don't have this value or this value, but we have them added up. So if we called this x, we can call this here, the dotted line, 72 minus x. Because it's that entire segment minus the segment that is x. So we would get, well, let's make sure we consider these. 10 is to 20 as x is to 72 minus x. And you can reduce the 10 over 20 to 1/2, cross multiply and solve for x. This is the same thing here. 30 is to, this should be 25. Since the whole thing is 55, as 3x plus 6 is to 35. So just make sure you're setting these upright. We talk about in class how you could write the reciprocal and get the same exact thing, as long as you're doing it to both of them. For example, this here is how we wrote it, but we could have written it as 35 is to 3x plus 6 as, in this case I would write 25 is to 30. Notice that when you cross multiply, you're getting the same thing. 30 times 35, 35 times 30. Same. converse of the proportionality theorem is just stating that if these are proportional, this ratio here to this ratio here, then we know that these lines are parallel. We should remember what the converse is. It's basically the reverse of whatever theorem you're looking at. This theorem is stating that since the lines are parallel, we know that these are proportional. So we're doing the reverse of that. So check these values. What is this? 91 minus 56. It should be 5 minus 50, 35. And this should be 30. So if 35 is to 56, as 30 is to 48, if these check out, gotta reduce them, but if these check out, then you know the lines are parallel. But you need to make sure that those are proportional, that these ratios are the same. Okay, I'll pause this video here, and then we'll finish with the second video with the rest of these.